universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Well, hey there. Hello, everybody, and welcome to Sky Tour Radio for this Sunday night, October 16th, one day before my birthday. And
Ooh,
tonight,
happy birthday tomorrow.
Thanks, Tara.
Happy
Hi, Daryl. How are
birthday.
you down there?
Hello, Mark. I'm good. Hello, Tara.
Hello, Daryl. Hi.
I thought it was going to be a boys' night out tonight.
Oh, I couldn't let that happen.
Well,
Yeah, actually, Tara,
I
give us an
miss you
update.
guys.
Give us an update on the UFO Congress. I couldn't
Oh,
go
my
this year.
gosh.
glad
Tell us
you're
all
here.
about it.
Oh my gosh, I just got back about an hour ago from the UFO Congress. It's still going on. They're wrapping things up, but I've been there all week and I have been just privileged to have two good friends, and Karen Berard, who puts that on, and Alejandro Rojas, and they allow me to help them with the Congress, and I get to meet all these awesome people. So we've had a great time the last few weeks, a lot of cool workshops and speakers, and I am exhausted because I had so much fun. I stayed up all day, almost all night. We had the most fun with the Halloween alien costume ball.
Oh, really?
It was on Friday night, and everybody came up. Not everybody, but most everybody. It was in some kind of not formal, but costume of an alien. And we had Anunnakis, we had reptilians, we had people from the Pleiades there, you name it. And some people just named it themselves, but it was hysterical. And it was a dance party. And I can go on and on, so I'll stop. But
No, I want you to
great.
tell me. I want you to tell me what Alejandro dressed as.
Alejandro.
This is Alejandro Rojas, Open Minds, and also
I want to say he dressed as himself.
what? He's not an alien.
Because he was emceeing, and Alejandro always wears a nice suit. He looks very snazzy and snappy in his suits. And even today, the last day of the Congress, he had a tuxedo T-shirt on. So
Okay, a tuxedo T-shirt. Well, that's
Yes.
that's the ultimate in like, okay, I give up.
he looked really nice, though, as
That's
always.
cute.
So it was really fun. There were so many so many speakers. I can't mention them all, but
Sure.
it was just full of information, and I highly recommend people go to this. It happens every year, usually in Arizona, Phoenix area, and it's several day event with lots of speakers, workshops, events in the evening. They also have a film festival. James Fox was there premiering his
That's
new
right.
film,
I saw that he was there.
and Dave Marler was there, John Ramirez, John Dover, one of the Navajo Rangers was there. There's so many people. And normally Marianne is always there, but she had commitments this year, but she's usually a big part of that as well. And it's just really fun. So,
She's up in northern Arizona right now
yes.
with two other folks, and she's on some kind of a hunting trip with them. So
Having a great time in this rain.
yeah, you know.
Seriously.
So I'm glad that went well. I've spoken at the UFO Congress many times, and
Yes.
I've never ever had a bad experience there.
How
Karen
could
and
you?
Alejandro, both put on a great show, and they take good care of everybody, not just the speakers, but everybody.
They do.
So I'm glad that it went well and so forth. I wish I could have gone.
Oh, it would have been great to have you there. That they're very generous people and just want to help spread the word. And it's a great place to network, get to know people, and just really fun, smart, intelligent, cool people. It's just fun. All of them.
Yeah, very cool.
Yeah.
Yeah, Daryl, I don't know that you've been to too many UFO conferences, have you?
No, I've never been to a UFO conference.
actually, there's something for everybody there. Like,
There is.
I'm doing a talk in Danbury this weekend, Danbury, Connecticut, at a UFO conference here, and it's going to talk about something that I've talked about before. Actually, what I did in Denver, it's the UFO propulsion concepts that I think is
Cool.
how these ships might actually really function using physics that we are close to understanding. It's not like you're not just saying, well, it's plasma and they go in multiple dimensions. It's like, no, you have to use some real science to put terms around those blanket terms to actually understand what's really going on. And so that's what this talk does.
That's the one Isabella was telling me about. She's very excited.
Isabella Melamed from Sofia, Bulgaria, is one of our Sky Tour live stream regular. She does all the table of contents for us, and
she's awesome.
She's really good, yeah. And
she is.
She's all the way from Bulgaria. She's going to attend this conference via Zoom. Everybody can do that. It's the Danbury Library Conference, UFO conference, and it's great. It gets great attendance, a lot of people, and I just think it's going to be a lot of fun, you know. And then I'm going to be speaking for the St. Louis MUFON group this week coming up before that conference, and I'm going to be talking about the similar kinds of things that they asked about as well. So it'll be kind of fun, you know. But you know, why are you here? You're here for Sky Tour Radio, okay? And you're also here for Sky Tour Livestream, which is this is the companion multimedia show. I guess we can't call it a radio show anymore, can we? Maybe it's like a kind of like a podcast.
Yeah, I think that's what a lot of people call it. I don't know.
I guess that's true. It is on KGRA.
It's a rose by any other name.
Right. It's the KGRA that sponsors us and lets us do our show. And Sky Tour Livestream is actually on YouTube. And if you want to see where we are on YouTube, well, that's actually pretty easy to find, okay, because it's right here at the bottom of the screen. This is our portal to the observatory out in the Arizona desert. It's actually the portal to all the observatories that we have. We have two. The East Coast Observatory is still being overhauled. Prices on construction materials has started to come down. So we're looking forward to building this new building out here to put the telescope you see right behind me over there. That one, that's the telescope for the east side. It's been rehabbed back there here in my ship office. And it'll be in that observatory once again. We used to have a dome out front here, a real dome. It looked like a minion. We decorated it as a minion for Halloween one year. That got a lot of really interesting attention. But we actually sold that dome because we outgrew it. It just got too small with all the equipment that had to go in there. And I've got a spectroscope now. It's going to add so much distance off the telescope that these things have to go, that it becomes a very cramped space, you know. And in fact, the telescope could hurt you if it swings around with all the stuff hanging off it. So you got to be careful, right?
It's amazing the commitments we make when we really get into this. When I got my 16-inch telescope, I bought a minivan, and that was big time for me.
Wow.
That changed my life. If I'd been married, I would have gotten divorced over that telescope.
Well, a 16 is huge. That was a Dob, right? A Dobsonian?
Yeah. It's an old Meade Dobsonian.
Wow. Now, Dobsonian, I know the people have heard us talk about telescopes, and we talk about reflectors, refractors, and Dobsonians. Daryl, why don't you tell people, actually, the differences between them? I know you know them off the top of your head, and go for it. Just tell them the difference of these telescopes.
Okay. I don't have a picture up, but
That's all right.
a Dobsonian was invented by a man named John Dobson, who was an old Catholic priest. He came up with the design. It's just a Newtonian telescope tube assembly invented by Isaac Newton. It's got a mirror in the back and a small mirror in the front at a 45-degree angle, and it bounces the light cone out the side of the tube up toward the front to where the focuser and the eyepiece is, and that's the Newtonian tube assembly. What Dobson did was he built a mount and he was into low budget stuff. He made it out of he made the tube out of a cardboard tube, a piece of sonotube, actually, a concrete forming tube, and the mount was built out of plywood, I believe. It lets the telescope pivot up and down in altitude and left and right in azimuth. And Dobsonian's saying was bringing astronomy to the masses. He came up with the Dobsonian design, and he used to go out and set up on the sidewalk. He helped form the sidewalk astronomers, if I remember right. I think they were in San Francisco, if I remember correctly.
That's right. It was.
And tons of people now have and use Dobsonian design telescopes. And Dobson, he never got a cent for it. He let it go. You know, he didn't have a patent or anything of the sort. He just turned the design loose out there for people to use, and now you have tons of Dobsonian telescopes all over the world. The one I have, you can see it if you go on YouTube and look up Ed Ting, T-I-N-G, Ed Ting. He has a video about the 16-inch Meade Dobsonian, and he talks about all the downsides of the telescope.
Well, he's in my state. He lives here in Connecticut.
Yes, he does. We should have him on sometime.
I'm going to actually look for him. I can't find him yet. I got to look for him.
He's a cool guy. But he does one video about the Meade 16-inch Dob and talks about what a pig it is. And it was, let me tell you. Again, I had to buy a bigger minivan just to haul the thing around when I'd go camping and stuff and do my summer star shows. And that changed my life. And I hated that telescope. I still do. It's been an ongoing process now for nearly 30 years to come up with a new design to make it lighter and a little more user-friendly.
You could convert it to a truss and then put it on a German equatorial mount.
If you look up Portaball, Portaball, that's what my design has always intended to follow. They don't build portaballs anymore, but it's a really cool design, and it's relatively lightweight. And that old equatorial mount I built, the pipe mount I built for my 8-inch f8 red Newtonian, I've thought about either recreating it or buying the parts to change it over to hold that 16-inch telescope.
Wow.
But it'd still be big and heavy.
Yeah, so John Dobson created this amazing telescope which has taken amateur astronomy by storm. Professional astronomers, not so much. But the amateur world has just seized it because it's a gigantic light bucket for fairly low cost. And that's really important. The amount of light you bring in is directly proportional to the diameter of that mirror that's capturing the light. If you think, your eyes are little telescopes that, like, say, 1 power, okay, to put it simple. And the size of your telescope is only the size of your pupil, okay? So you can tell how there's so much more data out there waiting to be seen. And the way a sensor works on a camera, which we've talked about before, is it accumulates the light that's coming in. Well, your eyes don't do that. Your eyes don't accumulate the light. It takes it and processes it and passes it on. Takes it, processes it, passes it on.
I've heard it can accumulate for about a quarter of a second.
But see, the thing is, okay, you're talking about latent vision and after images and things like that. And that's true. If you go into a brightly lit room, okay, and you shut off the lights and close your eyes, you'll still see the image of your room because that's the after image that's still being processed on the retina. And slowly that'll drain away, and it'll go away instantly as soon as you move your eyes. Because when you move your eyes, it's like a big eraser, and it takes out everything that's on the retina and clears that optic nerve train to go to the brain again. So that may be what you're talking about, Daryl. I've heard that too.
Yeah. But the idea is, though, that the bigger the aperture, as you were saying, it collects as pi r squared. If you double the aperture, you quadruple the amount of light you're collecting. And there is a line you cross at about 12 or 13 inches where the telescope just, it enters a whole new realm. it just changes. Everything changes with that greater light grasp. And the telescope, well, it's a pig. It weighs like 175 pounds. And I had to do a ton of modifications just to be able to move it out of my garage out to my driveway. But I put it on casters and stuff. But the optics, the tube was actually pretty decent. And it just showed me things I had never seen before.
Wow.
And I would really like to get it up and going again someday. I bought that thing back in '94, if I remember correctly. Had it ever since, and it's been a pig that whole time.
Wow. See, that's pretty impressive. My first telescope was a 2.4-inch diameter refractor called a 2.4. And I built a mount out of plumbing pipe, a German equatorial mount out of plumbing pipe. Now, the way the equatorial mount works is the one axis is aligned with the rotation axis of the Earth, and the other axis spins east and west, and the other one is pointing to the north, and you go up and down and left and right. But there's one axis that's always pointing straight up, so that, or to the North Pole, so you can always spin around that axis, and thus you can actually track the rotation of the Earth just by moving that axis a little bit toward the west every couple of seconds as the objects move out. It's pretty impressive, and it's a lot of fun. But building them out of surgical pipe was the coolest thing ever, because I just went to the hardware store and said, okay, that looks like that'll work. That looks like that'll work. And then I had to put a counterweight. So I had to get a rod welded into the last pipe there and put a counterweight on the end for the refractor. And it was the coolest thing. It was neat. And I gave it to some guy I used to work with. I know his name. And he just never gave it back. So I guess he liked it. I let him borrow it, and he just never gave it back.
He needed it more than you.
Yeah. Well, I made up for it since. I started with the Schmidt-Cassegrain telescopes, which are reflectors as well, but they're folded optical path telescopes. The light goes down and hits the primary main mirror, bounces up to another secondary mirror, then goes back down through a hole in the middle of the main mirror. So it goes ding, 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 primary to the secondary through the hole to the camera or to the eyepiece. And if you unfold that optical path, well, then obviously it's a lot bigger, isn't it? It's going to be 3 times that length if you were to make it like a long telescope, effectively, because you're cutting it down. Those are easier to maneuver, easier to move, easier to mount, and easier to manage and maintain, in my view.
All telescope designs have limitations.
They do.
And Schmidt-Casses are included in that. I've shown my red 8-inch f8 Newtonian before. I designed it. I built it from scratch. The mount for it is also a pipe mount, but it's an equatorial pipe mount. The threads on the pipe, the piece of pipe that points toward the North Pole, that serves as the right ascension bearing, and it's also got a declination bearing on it, and it works beautifully. I put a lot of thought into that. I wish I had a picture up. I'd show it. I built that scope back in 1996, and to this day, it works great.
Well, see, that's what I was just saying. I made a German equatorial pipe mount as well, out of plumbing pipe, and I used the threads as the right ascension axis, and then another one for the declination.
Yes.
The only thing you have to be careful of is don't unwind it too much on the declination, or it'll fall off.
Oh, yeah, this is true.
But that's actually how I transported it.
Believe me, I know.
I transported it that way. I would unwind the telescope and take the telescope off the mount, which, of course, was necessarily very heavy.
Yeah.
And bring the mount out and then screw the telescope on. It was really kind of a crazy thing. But we did that to be able to follow the night sky.
Yep.
And that was the coolest thing.
I know there... oh, golly. I have pointed the telescope at Jupiter, I remember, when it was over in the eastern sky. And then I went inside, and I came back out many hours later when Jupiter moved clean over to the western sky. And it was not motorized, so you had to push it by hand like a Dobsonian you do. It's not motorized. But all I had to do was go out and push that telescope from east to west, in right ascension, in other words, and it came perfectly to the center of the eyepiece. It was that
Yeah.
well polar aligned.
Yeah. Yeah, I did the same thing with this little refractor, but then again,
Yeah.
that was a little refractor.
And mine, if you've seen the pictures of it, it's a German equatorial mount, and it has counterweights. And for the counterweights, all I did was I went to the used sporting goods store, and I bought some free weights, and
Oh, okay.
figured out how many weights I needed, how much weight I needed, and put on there. The only thing about it, like you said, it's heavy, and as I've gotten old, it's more of a chore for me to haul the thing around. If I was to do it over again, I'd probably build it out of aluminum pipe instead of a galvanized steel pipe, which the old one is.
Yeah, I did the same. I used the galvanized steel pipe as well, and and we're going to get to our topic tonight, folks. But this is so cool. Okay, this is what got me into astronomy, and what got Daryl going in astronomy too, is the ability to home grow your own advanced rigs in order to be able to look at the night sky. I thought about aluminum pipe, but as a little kid, I didn't know any better, right? But my dad told me, he says, well, we can get some aluminum pipe. And I said, wow, that's nice and light, nice and light. And I was thinking about it, but I couldn't get everything I needed in aluminum. So he then said, well, we could just go down to the hardware store in town here and get this big metal pipe, but it's pretty heavy. And I said, well, heavy's not so bad. So I ended up getting the heavy stuff and thinking, wow, I should have got the aluminum. But then I realized something. If that scope was any heavier, the aluminum pipe probably would have had some flexing, what we call flexure. And we don't, that could have probably caused the problem at certain locations where I was aiming it. So I think I was okay with the steel pipe in the end. The heavier mount is always better to go with than the too light amount.
This is true.
Yeah.
Darn, I had the picture. I don't see where to put it up now.
Okay.
Are the settings different? Present?
Yeah, present. That's where it is. And it is a new. They're a new setting. Yeah, pick present, and I guess you have to screen share it.
I don't see it. Okay, never mind. People have seen it before. Maybe I'll show it again sometime.
Okay. Well,
I want to see it again.
Okay, Tara, you win. You get to see it again.
I think you showed it one time, Daryl, and it was really cool. It's been a while back, though,
Yeah.
right? Yep,
Yeah.
I remember that.
Yeah.
It's very
Very
cool.
cool.
I'd like to rebuild the whole thing. Just, again, try to make it lighter, but also make it better.
That's right. Cosmic Ray in the chat says you could use PVC plumbing fittings, and I would caution against that, because every time you use the threaded fittings on PVC are not meant for repetitive use.
Well,
They will wear out.
actually, I did use a PVC plumbing fitting as the saddle to get the 10-inch tube assembly attached to the mount. It's a 10-inch to a 4-inch saddle is what it's called.
Okay.
But then I put a metal pipe connecting the saddle to the equatorial head, so it's never actually threading in the PVC itself.
Right.
All the motion is on the steel-to-steel pipe threads.
Yep. The PVC is meant for screwing in or fitting in and then gluing. And so that plastic is really not strong enough. I know because I've threaded PVC before doing model work for the Navy, and I can tell you that it became a disaster, because after repetitive use, the threads started to break out because there's really not a whole lot of PVC plastic holding them together.
Oh, is that showing?
Yes, it is.
That's it. You can see.
That's cool.
The tube assembly is a piece of 10-inch aluminum irrigation pipe. That's the mirror cell in the back, and the mirror is an 8-inch f8 Newtonian mirror. I bought many years from Pocono Mountain Optics in Pennsylvania. I paid $200 for it.
I remember that.
One thing I do different nowadays, that's a helical focuser, and I'd put a conventional Crayford or rack and pinion on it nowadays. The guide scope, the finder scope goes right there. It's missing here. and that is the 10-inch by 4-inch PVC or ABS. I forget, PVC, I guess. That's the saddle, and it's attached with the hose clamps that came with the saddle, and then it goes down to 2-inch pipe right there, and it's threaded into the head, and that's the declination axis right there, and there is the right ascension axis right there that the whole equatorial head pivots around, and that's a piece of 3/4 inch pipe, I think it is, with 25 pounds of free weights on it. And the mount itself, there was some geometry involved, and I put a lot of thought into that to figure everything out and put it where I wanted it, which was to give me my my latitude, which is a little less than 39 degrees north, and it's actually slightly adjustable there. I can slip that structural pipe fitting up and down on that leg to adjust it for latitude to a degree. But it works beautifully to this day. It's a joy to use. I cleaned up the pipe threads with lapping compound, and then I put Teflon pipe tape on the two axes, and it just smooth as butter.
Wow, that looks really pretty. I mean, and of course the red colors, that's very distinctive.
I like red telescopes. My first telescope was red, so I made that one red too.
Yeah, there's a company out there, guys, called Edmund Scientific, which made a little pot belly telescope that had this red belly. It was round. I forget what they call it.
Astroscan.
And was it the Astroscan? The Edmund Astroscan. Okay, yeah. And I worked at a science center where we had a few of those for kids to use. And they'd walk around with them under their arm like it was some kind of big gun, okay, looking at stuff in the sky. And it had a little mount, sort of like a universal mount. You put the ball in, and then it goes any which way you want. Okay, you can look up in the sky. But it would be on a tabletop because the telescope was only like, a foot and a half long, maybe, so... And the ball was only about 20 inches in diameter at the most. So it was actually less than that, like 15 or 18. So it's pretty cool. Neat stuff,
Yeah, well, my first telescope was in Edmonds. It was a 6-inch f6 Newtonian, and it had a red fiberglass tube, and that's why I like red telescopes.
Wow.
It's a beautiful color.
Right, yeah.
It's I forget, fire engine red or red baron red. I forget what they call it. It's powder coated.
My first telescope was supposed to be a Criterion RV6, a 6-inch Newtonian telescope. I even built an observatory for it with my father in the backyard of my house in Plainville, Connecticut. And in that yard, we had a rotating system with shutters that would open up. And I was so excited to put stuff in there. I'd just go and sit in there when there's nothing in there, looking around saying, the telescope's going to be in here soon. And I kept calling the Criterion, and they said, no, it's going to be delayed another 6 weeks. And finally, the worst day of my life was when I said to my dad, let's just cancel it. And he canceled it, and I didn't ever get my Criterion RV6. Oh. I did, in fact, get a Celestron 5, which is a 5-inch diameter Celestron. And that telescope was really something. I sold it for more than I paid for it when I finally sold it years later.
If you ever see that Edmonds Astroscan, it's a variation on what's called a bowling ball mount. Mm-hmm. The bottom end of the tube is just a great big round ball, sits in a cradle.
Yep.
And that is the same principle as the portaball. Mm-hmm. I have a 27-inch diameter fiberglass sphere sitting in my living room, actually, which is intended to be the base for the new version of the 16-inch.
Oh.
It gets really big really fast. I mean, the mirror has a 72-inch, it's f4.5 focal length, 16-inch cross aperture. And so, that whole scope is going to be big when I'm done, but the idea was to make it lighter.
Yeah, that sounds like it would be. Well, this is great. We've been talking about our telescopes and stuff. And, we use telescopes to look back in time at the universe, because everywhere you look in the universe, you're looking back in time, aren't you? We remember 3.2 million years ago, Lucy, wow.
Easy for you to say.
Right. Australopithecus afarensis in Africa Okay, at that time, the constellation of Orion, for instance, looked very different than it does today. If she looked at Orion back then, and Lucy was a female by genetic analysis, she would have noticed that the four stars in Orion on the outside were all blue and hot. Okay, Betelgeuse is a red giant as we see it now, but back when Lucy was around, Betelgeuse was a Type O supergiant, and it was actually a very, very hot blue star, among the hottest in the universe. So the universe does change, but on slower time scales than we survive within. There's a portable.
That's the portable right there.
Okay.
And
So
that's what I hope to build one day.
wow. Well, I like
That's
that.
different looking.
It's
Yeah.
called an infinite axis mount. It moves up and down, left and right, or any way you want to move it. It's an infinite axis, not just up, down, left, right like a Dobsonian.
But
The
you
general
pay a
operating
price for that.
principle is similar, though. Say again, please.
You pay the price for that. You can't like follow the sky with that. It's all manual.
That's true. People have actually built
Little
drives
racks.
for them, though.
Yeah,
I've seen them. I've thought about ways to do it myself.
You could do like Arecibo had an azimuth arm, for instance, and you could do another arm. You could do that.
One guy I saw, he used to work for Sky and Telescope. He built what was effectively an equatorial drive for those things. He just had some little motor-driven wheels that sat there, drove against the sphere, and pointed it up, down, left, and right.
Huh. Don't bump it.
Yeah. Portaballs are hellacious telescopes. They were very high quality, and they were very expensive.
Mhm.
That's always what I wanted to try to recreate.
Wow.
Anyway,
Yeah, I'm glad you found that. So, as I was saying, when we look in the universe, we see back in time, and but one of the things that we haven't been able to do very well, at least not with direct observation, is look back to the beginning of time for the planet Earth and our solar system. We have ideas what happened. We have theories. We have access to, say, the first minerals that ever appeared on the planet. But we don't have access to any kind of video or actual historic record of what happened at that time, other than the fossil record and the mineral and geologic record. And that's kind of where we're going tonight. And so one of the things I wanted to talk about was the geologic time. And, I don't know how you've all heard about, geologic time. They talk about, they talk about the Paleozoic era. They talk about Jurassic era. Or the Jurassic, age, or sorry, Jurassic, not the Jurassic age. It's the Jurassic period. Okay, you've heard about the Permian period and so forth. And we talk about millions of years ago, hundreds of millions of years ago. Which is which? What does it all mean? And it's kind of what we're going to do. But we also have some really cool visuals to show you, showing you literally what happened to the Earth from the very, very beginning. And this is cool. But first, let's just talk about what these different ages are, so to speak. Okay. Now, if we go and let me bring this up here. Okay. At the top here, you see the Cenozoic era. Okay. And you see next to it, it says Quaternary, and then it has Holocene and Pleistocene. Okay. These are terms to describe different periods of time on our planet. Okay. Now, that yellow one at the top, the one that says Holocene at the top in the center there, that right there, that's us. That takes us up to modern day. Okay. Now, we talked about Lucy a moment ago. Where was Lucy? Well, Lucy wasn't down in the green or the light blue or the purple. Lucy was actually down just below the Pleistocene, right there in the Pliocene. Now, that's where Lucy was. So, Lucy was actually around right in the middle of the Pliocene.
she was about 2.5 million years ago, right?
3.2.
Okay.
Yeah, 3.2. Yeah, I've at times rounded up to 4 million years, but it's actually 3.2 million years.
They keep backdating all those numbers.
They do, and so I try to keep up with the latest things. But when you look at this, okay, you look at this in this yellow region, for instance, okay, that is something really important to understand, is that we came from there. That's where we are, is in the Holocene, this area right up at the top in the yellow there. Okay, now the Holocene is 11,000 years ago to today. Okay, effectively, that's where modern humans evolved from 11,000 years to today. And of half of that 11,000 years, we really didn't track our history or write it down. We did petroglyphs and pictographs and caves and petroglyphs on cliffs before that. But it was only until about 5,000 years ago that we started to actually manage our history and start recording it. The ancient Sumerians started doing that, and they did it using this cuneiform tablet pecking language that they used. And that is the kind of thing, Tara's over there smiling. She knows about the cuneiform language. Okay. So that's when our written history actually started. One thing to point out too is when you look at this whole thing over here, okay, this whole range of times all the way through the bottom there to the purple. If you think about it, we didn't have anything really big happening on this planet creature-wise for 90% of the time that the Earth was forming. So all that time frame on the left there that you see, or in the middle, all those red zones there, the Cenozoic, okay, the Mesozoic, the Paleozoic, and the Precambrian. Well, there's a lot more before that, incidentally. There's the Hadean and the Archean. There's times when the Earth was all a big molten blob, which is when the moon formed and it got struck by the moon, struck by Theia, this hypothetical object. Well, at that time, when that happened, that's when all this started to change, and the appearance of the moon led to a certain path of evolution. Daryl and I were talking about that, I think, once before, right? We were talking about the way the moon affected with tides and stuff. And
oh yeah, many times.
Yeah, and and until we had water on the planet, that's when first of all, when the Earth was molten and the moon was molten, there was still drag induced on the Earth by the gravity of the moon. And it still affected the crust of the Earth when there was no water on the Earth, and just ice, for instance, okay, where you had ice, solid water, basically, right? And it was also affecting and dragging that as well. But then when the oceans formed, we had this tidal bulge, which was sloshing. And that sloshing was created by the sun on one side, okay, and the moon on the other. And that slosh process is what led to a number of events that occurred on our planet, which bring us to where we are today. Now, what I'd like to show folks, and we're going to come back to all this stuff here. Don't worry about it. You're not going to get a test, and you're not going to have to memorize anything.
Whew.
But, yeah, I know. Huh? Who are you? Okay.
Could you put that back up for just a second? If you look there, right between where the yellow turns to green,
yes,
Cretaceous in the green and Tertiary in the yellow,
yeah,
that is when the dinosaurs died, right exactly on that line between the green and the yellow. Cretaceous Tertiary boundary.
That's
and,
right.
I think they've even changed the name of those nowadays, but
well, they call it the KT event, the KT boundary.
Yeah, and that's
still,
when Chicxulub happened, right there on that line.
Yeah. And that's actually the reason why that line's there.
Yep.
Okay, it's not that the lines occurred and wow, there's how coincidental that there was an extinction there. No, it's the extinctions define a lot of these lines.
Yep.
Okay, so and we're going to talk about the extinction here as well, but we'll come back to this. But right now, let me show you something else that I think is pretty cool. This next object, this next thing you're going to see, is a beautiful rendering of the entire history of the planet Earth. All right.
Huh?
Oh yeah. You just watch. Okay. Let's look at this. Okay. Up in the upper left, that's the temperature of the planet at that time. Down here is when this was. This is the actual time frame. Now, the eon is the largest amount of time. We talked about eons just a moment ago. And then you have the era, okay, which is the next smallest next smaller amount of time, and then there's a period, and then there's an epoch, and there's actually an age after that, but we won't worry about the ages because those are really highly refined dividing lines there. Okay, but this is neat, and if you look at this, okay, we're going to watch it change. It's going to start to go through the different eras. All right. So I'll stop it now and then, like right here. I want you to notice something, okay? In the upper right corner here, at this time, 4.47 billion years ago, literally just after the formation of the Earth, okay? Right there, 60% of the atmosphere was carbon dioxide. See that in the upper right? We had 19% water vapor. And look at now, where's the oxygen?
No oxygen.
There is none. That's right. There is none. And this is in what's called the Hadean eon. Okay. Hades, remember, hot, hell, devil, fire. Well, that's why it's called Hades, the Hadean epoch. But no, eon. But notice right here, okay, just what Daryl was talking about before. Okay, the formation of the moon occurred just around this point. And that's the whole impact hypothesis where this object called Theia collided with the Earth. New simulations show that when that object struck the Earth, it formed two blobs that came off the Earth and started orbiting the Earth. And the bigger of the two blobs, all right, was a very, very large chunk of Theia and the Earth. And that got reabsorbed into the planet. And that smaller one was hurled farther away and eventually became our moon. And that's the running theory right now. And the other thought is, and Daryl and I talked about this earlier. I think you weren't here yet, Daryl, or maybe I don't remember when we talked about it. But the theory was that maybe the moon formed in just a few hours. I agree with Daryl, who thinks that's not true. I have to say that you have to define what it is that formed. The mass that was thrown off could have been formed in a few hours.
Yes.
But not the final finished moon that is cohesive and finished forming. It was still accumulating stuff for probably 1,000 or more years, 10,000 years perhaps even, while it was orbiting the Earth. Because I have a feeling that the Earth had a ring around it of this material that eventually impacted the moon as well. But Theia, the remains of Theia that had formed this in the first place, actually got reabsorbed into the much larger gravity well of the Earth, and that's what I think happened. So that's just my thought.
Well, if you consider, if they think the moon formed in a few hours, as this modern thinking goes, the Earth is 8,000 miles in diameter.
Yes.
And if Theia was the size of Mars, say it's 4,000 miles in diameter, sizes and speeds might have been somewhat different back then, but just for an over-the-thumb guess, the Earth nowadays moves 18 miles per second through space. Mm-hmm. And if Theia was moving at something comparable, at 18 miles per second with a diameter of 8,000 miles, it would have taken a while for the Earth to sweep through its own diameter in space, shall we say. And yes. If you can imagine those two bodies colliding, it's not like it hit bang like that. The collision itself would have taken time, like a matter of an hour or several hours.
I would actually wager that it probably would have taken a number of hours. I mean, if you imagine, if you, for instance, do a real-time simulation, which we've done, we can do real-time computer simulations, and we've done it. It shows, the asteroid Ceres striking the Earth, and you do it at real time, you're going to see that it doesn't all happen in just 10 seconds. It takes a long time. To see that resolved, it'll take over 3 hours just to watch that collision resolve.
Uh-huh.
So I do believe that when they say it formed in a matter of hours, I think they mean a separate, distinct object that was visible, separate from the Earth, was formed by then, and that's possible.
Yeah, well, you might say it coalesced in a matter of hours.
I don't even think it coalesced in that amount of time. I think it was just a distinct series of blobs
Yes.
that would have been what we would call the moon, and a distinct series that would have been that other larger one which would reabsorb to the Earth.
Yep.
But the one thing to notice on this right here, if you notice right here, this was molten Earth. The entire planet was molten 4.47 million or billion years ago. Now, at that time, go ahead, Terry. You want to say something?
As I say, it looks like the sun with sunspots or something.
It does. It's a molten Earth, right? Now, what's interesting about this is where the atmosphere started forming. Just around this, about 4.5 billion years ago, is when the atmosphere actually started to form. And you can see from these constituents over here, you can see that it wasn't anything we could breathe. It's actually, I guess in a way, more similar to what it might have been at Mars. You know, when Mars, the way Mars is now, it's got like 98% carbon dioxide. But this is extremely volatile and not anything that we could breathe.
Yep.
We could not survive in this.
Don't see oxygen at all there.
Exactly. We said that before. There's no oxygen at all. And that happens a little bit later on, as we'll see. So we keep moving forward. Notice also that the day is getting longer. Now, what are you seeing here? You're seeing these are all the impacts over time, all right, from this large, this heavy bombardment era that occurred. Then maybe that heavy bombardment era came from material that was around the Earth that had originally was part of this Theia moon creation impact.
Yep.
Maybe that's what happened here. That's my theory anyway, and I think that it's right. And so this was around this time that we actually could get the oldest minerals, all right, the zircon crystals that were found. And so then those were in Australia. So that's when this occurred. And this was like 4.3 billion years ago. And so now we're actually heading. This is all called the Precambrian era because it's before the Cambrian, where we had the first explosion of life to occur in our oceans. All right. Now, at this point, 4.2 billion years ago, this is sort of like the earliest, interesting. It's controversial, but it's the earliest date that we think there might have been life on the planet. And it's also a time where the crust was solid enough to form separate plates that would ride against each other and cause that plate tectonics that we're so familiar with. And notice the carbon dioxide now, nitrogen's 31%, carbon dioxide 64%. All right. So, we talk about global warming. Can you imagine the 64% oxygen or carbon dioxide in our atmosphere? It'd be the end of us for sure. So moving forward again, we're still in the Hadean era here. And it takes a significant amount of time. Notice the temperature of the planet now, 83 Celsius. That's pretty good, down from about 10,000 Celsius. Not bad. We're going to zoom ahead here a little bit. We'll get ourselves to about 3.5 billion years ago. Okay. And if you notice now, carbon dioxide is now 0.85%. So, we're starting to see the atmosphere change. Now, a lot of it's from volcanic eruptions that are occurring, putting and spewing components into the atmosphere. All these things that are really important to see. But we also have at this time, right, with the formation of the oceans, we're also getting the first bacteria forming on the planet. The first bacteria. And it's around this time, and again, we don't know for sure, but it is around this time when that happened. And they were, of course, the cyanobacteria, which became the little percolators that actually built up our atmosphere for us. So I don't want to get too far before we have to go to a break. What time is the break?
We have a few more minutes. I think 7-8 more minutes around, approximately.
Excellent. Okay, great. So we'll keep going here. And so as you see the time scale of geological time go there as it's going by there. Okay, here you see, as I mentioned, the first cyanobacteria occurred around 3.4 billion years ago. That is kind of controversial. We're not really sure. Some say 2.5. billion years ago. Some say 3.4. That's kind of pushing it back further. But all of that means something to us. All that means a very important developments. And one of the things that's important to know is that we have fossils to tell us that this is so. And those fossils are listed right down here. They're called stromatolites. And those are mushroom-shaped formations, but they're mats of algae. And they love the sun. They're photosynthetic creatures. They use the power of the sun to make energy for their life form, for their life existence. And as they die off, well, then sand and stuff hits that layer, and it's sticky, and then it sticks to there, and then stromatolites form on top of that sand layer. So over time, you get this large ballooning mushroom cap-shaped object, and that's what a stromatolite is. And it's hard. It's made of sand and compacted materials that were created when these little algae died. These algae mats died and were replaced by sand and so forth that stuck in where their bodies used to be.
The goo.
Yeah, that's right. That goo is you. Remember that from Star Trek, The Next Generation? Right. It was Q. John Delancey said that Q is you, Jean-Luc. I love that. So yeah, so that was like around 3.4 billion years ago. And if you notice, we're still in the Archean era, Eon rather, and we're now the Paleo-Archean era. And we're still a long way away, and we're still a long way away from life. And if you notice, this is around the first time that photosynthetic creatures, notice the time frame is now went from 3.5 to 3.3 billion years ago. First evidence of photosynthesis occurs at this point.
Yep, and at this point, you're going to start seeing oxygen show up here at the upper right.
I would imagine that's true. Let's find out. Well, with the time we have left before the break, let's watch and see. I have no doubt that's true. Notice now the daytime is now an 8-hour day cycle, right? I'll jump ahead a little bit here. All right, and we're going to start to see oxygen showing up here. It does take a long time for the oxygen to start becoming a well-known presence, but once it does,
there it is.
Like there, let's just do it right here. Okay, you'll see it. There it is, up there in the upper right, 0.01 then 0.02%. Now it's about 3 billion years ago. Okay, now this begins the event known as the Great Oxidation Event. And that's the GOE. And the Great Oxidation Event was where oxygen started building up in our atmosphere way faster than previously thought. And this website, by the way, I'll give you so you can actually go out there and check it out yourself. It's replete with this tremendous amount of stuff. But notice this. Not much is changing anywhere else, but all you're watching change here is the oxygen level. Oxygen went up to 0.2% really quickly. Now, interestingly, there are certain events, that look at this. There's certain events that cause oxygen to go down to almost nothing again. Okay.
Snow.
Well, no, but there are extinction events that actually cause the oxygen to die out too. But we're also talking about 2.8 billion years ago when we didn't really have a good, and we still don't have a good handle on this. So oxygen, though, does make a rapid comeback, and we'll see that very soon. So as we jump ahead here, all right, you notice how it's starting to come back now quite heavily, and it goes back and forth. All right, and once we're out of the Archean, that's when things begin to change. And now we're over 1% oxygen. All right. Now you notice that it shows red. Okay, let me show you what that is. That's pretty cool. Okay, so there's oxygen in the atmosphere now, and there are this actually ended up causing a lot of rust to build up in the ocean from iron compounds, and so that actually caused the oceans to possibly be red, like the red tide. But it was probably like a ruddy brown, probably not like red tide. But then, what's this? Well, at this point, we could have actually had this glaciation that is something that occurred where we had what was called a snowball Earth condition, and that's possibly what happened, around 2.2 billion years ago. And we've moved into a different era. Okay, we're in the Paleoproterozoic, and we're in the eon that's called the Proterozoic eon. So we got a lot going on there, and I'm hopeful that we'll have time to move a little further ahead. I think that we have a break coming up here.
Less than 2 minutes.
Okay. Well, we have a few million years we can go through.
Yeah, about 1 minute.
Yeah. So note the time of the day. The length of the day has now gone from 4 hours, way at the beginning, to 13 hours, 25 minutes by 2.286 billion years ago. So that's the effect of the moon, inducing a drag force, basically, and causing the tidal bulge on the planet that causes this to occur. And that process, now why are all these things floating around? Well, because this is plate tectonics. We have crustal plates that are actually floating around on the mantle, even during snowball Earth. All right. And we have other events that are listed here as main events, which I think are pretty cool. And as we move forward, now move into another time here where we have this red ocean occur. We have this thing.
We need to break.
Yeah, you gotcha. And we have this nuclear reactor, which we'll talk about when we come back. All right. But thank you for joining us, and we will talk to you in just a few minutes.
DB app is now available on iOS and Android devices. Gain on-demand access to any KGRA DB programming. Download any show directly to your mobile device to listen or watch on the go. Go to the App Store and search KGRA DB.
The experiencer phenomenon is happening for a lot of people just like you all over the world. People are telling very similar stories about personal encounters with non-human intelligence. The Mutual UFO Network has research, resources, and support to help you make sense of what is happening. Our experiencer community is growing every day. Join MUFON, find your friends.
Hi, I'm Austin Butler from Baz Luhrmann's new film, Elvis.
Tomorrow, all of America will be talking about Elvis Presley.
As a blood donor himself, Elvis shared the gift of life with patients in need and asked others to do the same. We're encouraging you to give blood this summer. Please visit redcrossblood.org/Elvis movie today to learn more.
You're listening to the KGRA Digital Broadcasting Network. We provide unparalleled coverage of trending news in the world of ufology, cryptozoology, and paranormal phenomenon. Whether you're watching our video live stream or listening to one of our audio programs, you are getting the best from world-renowned researchers and hosts, guiding you through topics the mainstream won't touch. Miss one of your favorite programs? No problem. Head over to the members area at kgradb.com for access to our massive library of award-winning content. Make contact, stay connected, only at kgradb.com.
Hey, welcome back to Sky Tour Radio. I think I'm Mark D'Antonio. I'm sure that's Daryl, and I know that's Tara. But hey, welcome back. Before the break, we were talking about the history of the planet, and we talked about this diagram here, this wonderful video. Again, I'll share the link with you. At the time, it was around 1.5 to 1.9 billion years ago when this particular natural fission reactor was starting up, I would say. Now, fission reactors are very dangerous. We know that, and we know that when you have too much uranium in close proximity to other uranium, it's going to get hot and it's going to start, decaying. It's going to start shooting off high energy particles. Fission, yes. Okay. And so that's actually what happened at this site in Gabon in Africa. It was uranium-235 in the ground, and they discovered that the expected percentage of this uranium in the ground was less than it should have been. And then they found in this rock strata, they found what looked like the components and the resultant products of fission from uranium. And they were astonished. I think it was the scientist Perrin, who discovered it. And they found that this is a location on the planet where a naturally occurring fission reactor was occurring because this was a concentration of uranium, and this fission started occurring. So personally, I'm interested in that because that tells me that I wonder if any of the living creatures in that region, of course they're going to be the cyanobacteria type, would have been damaged, injured, mutated by that radiation, by those byproducts of the radiation. Don't know that, but it's pretty interesting how that all comes about. So that's the Oklo nuclear reactor, and that's when it started. That was when it became active around then.
Is it still going to this day?
I'm not sure about that because it's a mine now, so they're mining stuff out. So they're mining stuff out.
Isn't that dangerous? If it's a reactor, sort of.
It's a natural reactor. Yeah, exactly. So I'm not sure, but I know there's what's called, it's actually the Oklo uranium mine, I believe. Okay. Notice, incidentally, right here it says we're 1.8 billion years ago, and over here in the green you see first eukaryotes. Now, what are those eukaryotes? Well, those are creatures, little cellular single cell creatures that actually end up showing a nucleus. That is to say, a nucleus inside of a cell. Up to this point, they were not eukaryotes. They were actually prokaryotes, where they didn't have a cell structure with a nucleus in the middle. It was just a cell structure with a cell and material inside. The eukaryotes sported a nucleus inside, and it's in those nuclei where other processes could take place that supports life. All right. Very, very important stuff. The replication of DNA takes place in those locations in the cell. So these are really important developments that occurred on the planet at that time. Now, moving forward, okay, and I am going to zip ahead here. Okay. This is, okay, well, you can look these up too. But the Sudbury Basin impact was an asteroid about 10 to 15 kilometers wide, and it actually struck the Earth up in Canada. And these impacts from asteroids actually brought different minerals to our planet that we could benefit from. And so the Sudbury impact is one of those that brought minerals up that were very important. Now, you'll see that we're getting, again, we're now at 1.7 billion years ago. Notice that we still have basically single cell life existing on the planet. All right. So for several billion years, it's just single cell life. We don't have anything else yet. All right. Oxygen's only at 1%. So those little guys are working pretty hard. So moving forward, okay, now we end up, now this let me go back there for a second. There is a impact, which I actually tried to look up, called the Shoemaker impact. it says the age is highly disputed, but it's commonly thought to have occurred at this time. An impact, and I think Shoemaker, you think Shoemaker-Levy comet, but I'm not sure if it was an asteroid impact or what. I can't find any information on the Shoemaker impact myself because there's too much stuff out there on the Shoemaker-Levy impact at Jupiter to differentiate. I've never heard of this impact, so I'm not sure where this came from.
I bet you it's the same guy, though. Shoemaker and his wife, they were a team.
I'm sure. And notice, of course, the length of the day is now 16 hours, 31 minutes. Again, thank you, Mr. Moon, for dragging and stealing some of the angular momentum of the Earth for itself as it moves further away from the Earth as it does so.
Yep.
So that's
conservation of angular momentum.
You got it.
I have a question.
Yep.
Has Gondwana land formed yet?
No, we're still in the Proterozoic eon. We're not there yet. You see how the tectonic structures up here? This there is a name for this. What's the name of this guy? It's not Gondwana land. Rodinia. We're looking at Rodinia at this point. Okay, so this is Rodinia right now. This is the large landmass that's on the Earth right now is Rodinia. Yeah. And here's what's important here, too. At this point, we're noticing also that, let me just bring that up here. Okay, we have the first algae blooms, occurring, which are really interesting. But we also have the first fungi that make their way to the land. And that's huge because now creatures are colonizing the land. And that's extremely important. Extremely important. There it is. And so they spread across the land. So maybe the fungi were really fun guys.
Hey.
There's a fungus among us.
I knew that was coming. I knew both those were coming.
Well, I threw it out there, and I wanted to see who was going to do it first.
Yeah.
Okay. Now, at this point, this is very important. Of course, it's all important. Right now, at this point, 1.2 billion years ago, now the inner core of the Earth is formed. In other words, it was always there, but it was a molten mass that had cooled. And so now it's becoming more of a hardened object. All right. And so that means that the outer core around the inner core is now free to move around it and cause the charges to be built up as it does so. The building up of charge is what generates our magnetic field. And that's the thing that protects us from the deadly rays of the sun, like the ultraviolet radiation, because our sun was young at this time and was really quite powerful. You would probably not survive outside for long without a hefty dose of sunscreen back then, because the sun was pretty powerful at that point. And the day is now 18 hours long. You might not notice the difference. Okay. And that's 1.2 billion years ago. So now, again, we still...
All right. Evolution of sex.
Yeah, at a single cell level. Okay, if that excites you, more power to it. More power to you. Yeah.
But which sex was it?
Oh, I think both of them. And there are only two, by the way, just so you know. I mean, I don't think there's more than two. Contrary to popular belief in the media.
Anywhere or in the universe?
Remember what Jethro Bodine said on Beverly Hillbillies? Uncle Jed, he filled out a job application, I think it was, and that was in the days before people called it gender. And on the application it said sex, and he wrote down, "Heck yeah."
I said, "Heck yeah, Uncle Jed." Yeah. Okay, now we're about 1 billion years ago. And the actual, at this point, the first known animals now were really starting to show up in our oceans, of course. We started with the first we started with the Rodinia continent, and that continent finally broke up, and it led to the beginning of a new era for life. What I'm trying to say is life explosion, I guess. All right. But if you think about it, you look at the Earth here. Of course, this is the typical projections that you see, so you can see all of it. But you notice how the continents just seem to be floating. That's, again, the tectonic structure. Now, I saw these before. These objects right here that you're seeing here.
Volcanoes?
Yes, that's right, Tara. Good.
Cool. So the Hawaiian Islands, I can tell.
Well, yeah, we're a long way from the Hawaiian Islands. We're at 850 million years ago at this point. Okay. And right now is when this supercontinent's been breaking up here. That's what we're seeing happen here. Okay, but volcanic uplift and volcanoes riding on the mantle on the hot spots are causing these islands here. And you'll notice that they're all kind of coalescing. Very interesting how that happens. So now we have the breakup of Rodinia here. Okay. And then again, we have another glaciation which occurred on the planet. And there's a couple of times when they say that there was a great snowball Earth a couple times on our planet. I'm not so sure about both of them, but I know there had to have been at least one. And so I think that's something that is really impressive. Now, during all this time, one of the things that's happening is we're seeing multicellular organisms by now, and not only that, we're about to start heading into seeing little shelled animals with shells, right? As we get to the next era, all right. And let me just take us up to that. All right. Now, here's something that's important. See, this says the Avalon explosion. Okay, never mind the names. There were different times in our history where there was just an explosion of life, radiative adaptations, where basically these common ancestors radiated out many different tentacles of mutated offspring over a long period of time. And some of those were naturally hardier and could survive more than others. And that's what's called natural selection. And only those strongest ones could end up coming out at the end. And that's what we talk about when we see these Avalon explosions or explosions of life.
And all of a sudden, oxygen is up to 18%.
That's right. Because we know that as we go through this, we know that those little cyanobacteria and phytoplankton are going to town in our oceans. It's like an automatic life-generating process. So notice the length of our day, 21 hours now. And now we're into the Cambrian period. This is the area of time when the Cambrian period is when we actually started seeing a lot happen. And what's interesting is 90% of the development goes by with only cyanobacteria in existence for a while. Okay, 90% of the time goes by before we start getting an explosion of life. So the question is that really how it goes? Is that natural? Is that what happens? You know, in fact, it won't be too far after 428 million years ago. It won't be too much longer until we start to see the first amphibians, you know, and teeth. All right. And then the first insects and trees and so forth. You can see all these notes coming and going so fast because there's an explosion of life, you know? And so that's really important to understand too, is these explosions occurred. Now, it's probably not related to the time of the day. Go ahead, Daryl. You were going to say something, I thought.
Well, I see it says formation of Pangea now. Gondwanaland came before Pangea, didn't it?
I think it did.
Yeah, I have to tell a story because we've gone by Gondwanaland. I was going to the hardware store one day, and I pulled into the parking lot, and there was an old, really beat-up International Scout four-wheel drive parked in front.
Okay.
and I saw there was a bumper sticker on the back that said "Reunite Gondwanaland."
Yeah.
And that sounds like a very hip kind of thing nowadays, but I knew what they really meant. And I was approaching the front door, and this old guy walked out. He looked like Mark, the Beard of Knowledge on Pawn Stars, the guy that knows everything.
Oh, yeah, yeah.
He had an old, like a forester's hat on, and a big old bushy beard and glasses, old fella. And he walked up to the International Scout 4-wheel drive right as I was getting there. And I said, "Pardon me, sir, are you by chance a geologist?" And he laughed and he said, "Why, yes, I am." And that's the whole thing. It's just, he is referring to when Gondwanaland, the first supercontinent, broke apart and eventually turned into Pangaea here that we see now.
Very cool. Very cool.
It was an inside joke, and I got it.
I mean, Gondwanaland, unless you're a geologist, unless you're a paleontologist, unless you're an astronomer and so forth, you're not going to know what Gondwanaland means or Pangaea.
You don't learn that in public school, yeah.
Yeah, you don't.
Well, it sounds hip though, like
yeah, right.
Sound like some some country that's
social activist cause.
Right.
Reunite Gondwanaland. Yeah, what he said. What's Gondwanaland? Exactly.
But do it anyway.
Do it anyway. That's correct.
See, so oxygen is up to 32% now. That's more than
correct.
Nowadays.
That's right. And if you notice, we're in the Permian period right here. The Permian period is one where the oxygen was the maximum amount it could be. And so you might think, wow, the Earth's well on its way, right? But the Permian period ended with the Great Dying, and it's right here. Okay, the Great Dying was the end of 98% of life on this planet. Okay, now it's 96% of marine, 70% of terrestrial. Overall, it averages out to 98% of the life on the planet. And what happened was there was a large volcano in what's now Siberia. And that large volcano erupted and put a giant lava cap over the top of this volcano. It wasn't a volcano like a platonic eruption where it just comes out of the cone. Okay, it was a large flat fissure eruption, and it sealed in the volcanic eruption underneath, and that led to lava below leaching out to the sides and going through volcanic dikes, where it ended up reaching carbon-based material, organic material that it literally vaporized as it went through, and thus that carbon dioxide became trapped as it kept moving out miles and miles, hundreds of miles, thousands of miles. And as it did that in all directions, there was a point in time where it broke through. In other words, it actually reached the edge of that main lava cap that had previously kept that eruption from spewing into any gases into the air. And I forget how many gigatons, billions of tons of carbon dioxide flew out all at once, all around the edges as this cap popped. And when that happened, the temperatures in the oceans and on land rose by 20 degrees Celsius.
Wow.
That's huge. Talk about global warming in just a few weeks. Wow. That led to the Great Dying, because you put too much temperature in water, oxygen can't suspend as well. Creatures that make oxygen can't tolerate it. They die. Oxygen goes down, and things happen that are very bad for the planet, right? And that's just what happened, And then over time, things cooled down. Okay, we ended up with other mammals that really occurred, and there was an extinction between the Jurassic and Triassic age as well. Okay, now we're at 186 million years ago, and 186 million years ago. That's interesting because we're talking about the time at which there were the first birds, right? So that's where the first birds occurred and came about, and that along with mammals. And so that was very, very important, obviously. So as time went on, okay, we saw a change in the planet. We saw the oxygen level had dropped back down to 15%. Okay, lots of new flowering plants. Flowering plants are very important too, because now flowering plants, you have to ask, well, what was the purpose of a flower? The purpose of the flower was to attract something, and that something was a flying insect. This is a symbiotic relationship between pollinators and pollen sources, right? So this is where we started to see the spread and diversity of plant life. As bees would pollinate flowers, they would also unwittingly take the pollen with them, right? And go for the nectar. They would then take the pollen with them and pollinate other flowers, right? It's that sex thing they're always talking about, but very, very slow and with flowers.
The bees do it.
Right? That's right.
Uncle Jed.
Hey, Uncle Jed. That boy ain't right. So yeah, so that's pretty cool, right? And of course, as you saw, we just saw it. It went by there. Okay, we saw the first bees actually. We had the first snakes, and then right there, the first bees. All right, and so they ended up co-evolving, as it says very rightly, with many different plant species because they're also, the ones that started doing the pollination in earnest. Okay, so
the bee's knees.
That's correct.
That's why you're sweet as the bee's knees. It's the pollen.
I didn't know that bees even had bees. Bees had knees. So yeah, so now you see there's an explosion of life occurring. You see all these things down here, and it's not going to stop. Okay, and now if you notice, the oxygen level is 23% at 17.4 million years ago. So it looks like we're actually reaching a pretty good stage right now. The other thing too is, let me just back up a little bit here. Let's back up a bit. That's too much of a bit. Let's do about, let's see where I want to go here. 17. I wanted to go to about 25. So we'll just go here. Okay. So right about here. Okay. This is where we first saw glaciers appear at the North and South poles. This is where the ice on Earth began to take up residence on a more permanent basis. All right. You had the glaciation, which came and went, but now we're getting permanent ice caps. All right. And that's where we're seeing now. Actually, it started at the South Pole for sure. And then it ended up going to the north as well. Okay. And so that's pretty neat. So there we go. That helps us figure out what's going on. And you'll notice now Earth looks like something is familiar to you at this point because this is where we are now. This is us. Okay. And so now we actually have at 0.0 million years ago, we have our north polar cap, we have our south polar cap. So the point I'm making is you saw that ice at the poles actually was very rare. And it's only in recent geologic history that ice at the poles actually occurred. And the North Pole was the last place to have it. So when people start talking about climate change, we really have to put into the discussion the understanding of how history occurred here. All right. Look at the carbon dioxide level. It's 0.04%. You know, people say, oh, the carbon dioxide is rising. Remember what it was back here? 0.43%. And then it was like, it was actually 0.3%, a third of the atmosphere was carbon dioxide for the longest time. All right. And now it's dropping down and it's just down to 0.04. That's actually very important because what it tells us is that carbon dioxide has its own set of cycles, doesn't it? Right? So we have carbon dioxide cycles as well, where we have more carbon dioxide at times and less. We have to just put it in perspective. The Earth is changing all around us. Now, could we affect it? Yeah, we can for sure. Obviously, we can affect the environment for sure. I'm not going to say no to that. I'm not going to doubt it. We play a role, but we have to understand that the Earth plays a much bigger role. All right, and so we have to put that into perspective.
There was a recent astrophoto of the day. They talked about I forget what they called it. Some cycles on Earth over periods of time, and we are actually running about 4 degrees centigrade below recent, geologically speaking, trends. We're actually 4 degrees C lower than what the average has been in recent time.
That there's a number of reasons why that could occur. I actually put forth the theory at one point that you look at all the jet contrails on the planet, and what the jet contrails consist of: icy particles. And what does ice do? Ice very, very effectively and efficiently reflects light, right, and radiation. So it's possible that a lot of jet contrails has slowly cooled the Earth off and allowed radiation to go back to space and not get down to the Earth's surface. Is that something to contend with? Maybe so. Maybe it is, maybe it's not. And that is a perfect example of how human-made objects, transportation vehicles and so forth, and human operations could actually cause a problem for the planet. Maybe it's causing the cooling like that because radiation won't get to the Earth. Right? On a cloudy day, it's much cooler on the ground than it is when it's sunny.
I have a question. How do you know that this permanent ice caps isn't the beginning of another snowball stage?
There you go. See,
that's a good question.
And that's a very good point. Okay. I mean, Earth has ice ages. We know that. And it's dependent on climate, solar cycles. I think that it's important for us to keep our eye on the ball and make sure that as stewards of the planet, we don't destroy it, because we can. Okay. But I also think it's extremely important to understand that the Earth has a mind of its own, and the Earth is going to do what the Earth is going to do. And just like there's no way to predict a mega eruption, okay, there's not going to be any way to predict the next ice age. And when I see people talking about, look how much carbon dioxide's in the atmosphere, I have the data on the carbon dioxide. You know what it does? It does this. It's going up, it's going down, it's going up, it's going down all the time. It's not just going up, 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 up. No, it's going up, it's going down. It's doing this all throughout the ages. I have a much finer resolution than this video here. And it shows the carbon dioxide levels fluctuating within a decade span for millions of years based on the rock strata and the chemical abundances found in the rocks.
There are two highly regarded science fiction authors. One of them has passed some years ago, Larry Niven and David Purnell. Larry Niven and Jerry Purnell, excuse me. They did a book years ago called Fallen Angels. It's a novel, it's science fiction, but the premise of the book is that the only thing that was keeping Earth from going into another ice age was human activity. And it gets political from there. I won't go into it, but it'll make you think. It's a very good book. Niven and Purnell did a lot of good classic science fiction, Ringworld, Remote in God's Eye, and stuff.
Yeah, we are at the point where we can affect our planet. There's no doubt. But keep in mind that the largest potential destruction that we can do to our own planet pales in comparison to what's already happened to our planet.
Yep. Naturally.
So we have to keep that in mind. I want to say, for instance, when we saw the DART project, and we talked about the whole DART project the other day on our last show, it was pretty amazing. Okay, to take a bullseye on this little asteroid from 6 million miles away. I thought that was a pretty good bullseye, and We got images from Hubble. Okay, we got images from the web. Okay, and as it turns out, we actually did move the asteroid. In fact, we moved it far better than we thought we would, which I thought was pretty interesting.
That's
They were
cool.
That's right. So it worked, and we managed to bring this asteroid closer because as the asteroid was going around Didymus, okay, we struck it on the other side to actually slow it down. And what that would do is that would slow it down as it's orbiting, and it would have to come closer to Didymus and take up a new orbit. And that's exactly what we're seeing it do.
There was a good amateur astronomer image of Didymus and Dimorphos the other day I saw where they managed to catch that tail that's been put off from Dimorphos.
Oh, yeah.
Since the impact. And they caught it quite well with just an amateur telescope.
I think that's pretty cool. That's pretty cool. I think, speaking of telescopes and so forth, Daryl, I'm wondering maybe since we talked about the geological record today, maybe we should talk about the astronomical record and have you take us out into the universe with the deep dive.
Okie dokie.
And then, Tara, if you have some questions, you can ask them during that time as well.
Sounds good.
Nice. All right, Daryl, take it away. This is the deep dive segment with D. Mason down there.
Here we go. Okay, here we are tonight from my location, Colorado Springs. It's a little bit before sunset. Last time we were here, Mercury and Venus were here, and now you only see Mercury, you notice, east of the or west of the sun, in the morning sky, in other words, though this is almost sunset. That's because Venus is sort of behind the sun right now. We can't see it. And we'll advance an hour. The sun has just set. Venus will be popping up in the evening sky here in the coming weeks. And once it does, it'll follow the plane of the ecliptic here, that red line. And over the following months, it'll get higher and higher and higher in the sky as we move on through next year. I don't have too much to show. There will be a couple of things I want to touch on in a little bit. But 6:30 at night, and we'll give it another half hour or so. You see Scorpius is setting already. I can still see Antares there, the heart of the Scorpion, at dusk. And once it's fully dark outside, Scorpius is pretty much gone for the year now. Sagittarius is well west of the meridian, that north-south line that passes straight overhead. So Sagittarius isn't far behind Scorpius. You see, it's going away. It's setting by a little after 9 o'clock at night now. Saturn is still in eastern Capricornus. Jupiter is still in western Pisces. And we'll move on over toward the east and the northeast, and that red line is the plane of the ecliptic again. Well, there is the Hyades, there's the Pleiades. Isabella was very excited last night. She saw the Pleiades through her window when she went to bed.
Nice.
And she had to get back up and tell me about it. So now here at 9:17 at night, the head of Taurus Ebola is rising already, okay? And we'll give it another hour. It's about 10:15, and you see Mars is already up now. And I told you about Mars a stream or two back. Mars is hanging out in the head or between the horns of the bull now, and Mars is about to, if it's not already started, moving retrograde as the Earth catches up with it prior to Mars being at opposition on December 7th. Mars will start moving backwards toward the Hyades star cluster here, where Aldebaran is, the eye of the bull. So it'll be hovering in this area for the next few months as we catch up to Mars and then pass it on December 7th and the morning of the 8th. And the other thing I wanted to point out is Orion is up by midnight now, before midnight. On the night, overnight of October the 20th here, 4 days from now, the peak of the Orionid meteor shower is going to happen. The Orionids are debris from Halley's Comet, good old Halley's Comet. Halley's Comet actually produces 2 meteor showers, the Eta Aquarids in early in the year, and this time of year we hit the other side of the comet's orbit and we get the Orionid meteors, and they appear to radiate. The radiant point is right here in the elbow of Orion's right arm. Do you see that? Orion's facing us, so there's his left arm, and there's his right arm on our left side. The radiant point of the shower is right there in Orion's right elbow. And the other thing I wanted to mention, I'm going to advance.
You talk about the eclipse? Lunar eclipse?
Yes, sir. And here it comes right here. On the morning of November the 8th, the moon is going to be in, Aries, I guess. There will be a total eclipse of the moon on the morning of November the 8th. It's going to be best visibility from the western U.S. You will be able to see at least the early phases of the eclipse from like the East Coast and the western U.S. It's actually centered. The prime view is out in the Pacific Ocean, but we will be able to see the whole thing from the western United States before sunrise on the morning of November the 8th.
Does that mean I've got to be up early to Sky Tour live stream that?
Well, that's up to you, but that's the general idea, you know. Time waits for no man or woman.
I know, but look what's waiting for you. I got a couple of shots there I'll just throw in here.
Okay.
So this is what's waiting for you when you look at this. This is a beautiful eclipse. This just occurred, this one. And what's neat about that eclipse is that the moon, you're seeing the Earth's shadow past the moon. And this part of the moon that you see red, it's seeing the sunset around the limb of the Earth. From the moon, it's probably a stunning red, a beautiful red ring around that part of the Earth. So it looks beautiful. But sometimes in other eclipses, things like this happen, which we saw before. This was in Sky Tour East. Daryl, were you? I keep forgetting whether you were on this stream with us. I think you were, weren't you?
I was, yeah. I was there when it happened.
Okay.
We didn't know it happened at the time. Somebody pointed it out to us, and later in the evening, and we went back and found the time it occurred.
That's right. And that time was 23 hours, 41 minutes, 35. That means 11:41 and 35 minutes, 35 seconds. On January 20, 2019, we're looking at a lunar eclipse. And down in the red portion of the moon, on the left side, you see that white dot. Well, we actually saw a meteor strike the moon and caught it during a lunar eclipse. Probably a once-in-a-lifetime thing. But I thought it was pretty exciting, Yeah,
now, we were one of like 5 or 6 telescopes in the whole world that managed to catch it.
That's right. There was only 5, actually, that were looking at the moon at the time and catching anything, and we actually caught it on film. I don't know if they all caught it on film, captured it. But we did, and that's a stream that's available at Sky Tour live stream for anyone to look at. Now, you mentioned Halley's Comet before. This is Halley's Comet. This is a photo of Halley's Comet. And when we talk about the Orionids meteor shower that Daryl was talking about, that comes from this part of the comet, the dust tail. This is the ion tail, which is noticed as markedly blue, but this is the dust tail. I did not take this photo. I was in Florida photographing Halley's Comet, and all those photos are on film in 1986, and I have since lost those films, which is sad but true. But this is the dust, and this dust, remains in the orbit that the comet takes, and we pass relatively close to that orbiting dust that goes around the sun. And when we do, we actually can see meteors strike, and that is what the Orionids are that Daryl was telling you about.
And Orionids are a decent shower. They're not a super shower like the Geminids or
Leonids.
The Leonids or Perseids. But they have a usual hourly rate of about 20 meteors an hour, and I believe Bill, New York Skywatcher is maybe going to show it
He is.
the night of
He'll be
October
doing it.
20th. That's this
Yeah.
Thursday night, I believe.
And that's Bill New York Skywatcher. Don't forget to go there and check it out.
Yep.
Bill New York Skywatcher, by the way, is also our esteemed producer and the man in charge, the guy that knows what's going on.
Large and in charge.
Large and in charge. That's correct. Yeah. And
disgustingly
much, so.
I'm sorry.
I'm sorry. That's okay. I just have to say that disgustingly so. He's also got his house entirely decorated for Christmas already. Come on, Bill.
That is disgusting.
It is disgusting.
Jeez.
He's laughing right now.
And the last thing, again, I talked about this last time. I'm going to go ahead 1 month, and you'll see. Well, I'll go there on the evening. It's the evening of December the 7th, morning of December the 8th, depending on where you are.
Oh, yeah.
I'll back up a couple of hours, Harry. Look there. The moon is right in front of Mars. Mars is going to be at opposition that night, and the moon, by definition, I would think, has to be full that same time. The moon is going to pass directly in front of Mars the evening of December 7th. It will be visible from most of the United States, the southeast U.S., and the East Coast, I think, will not see it. I have to go back and look again.
Which coast won't?
The East Coast.
Oh,
much of the East Coast and the southeastern U.S.
I think you're right. Yeah.
The moon will pass just above or below Mars. It will also be visible from Western Europe, also early in the morning before sunrise.
Okay.
So that's something to look forward to in December. And that's all I have for Deep Dive tonight.
Wow.
Unless there's somewhere you wanted me to go.
No, actually, I thought that's pretty good. So now we can actually go on with our next segment with our lovely Tara and her Tara's Cosmos. She's had to, come up with tons of questions along the way here. And as most of you know, she usually comes up with questions that many of you are thinking. So I think it's time to turn this over to Tara with Tara's Cosmos. Go.
Oh my God. Okay. Well, you were talking about slosh dynamics a little earlier.
Yes.
So what about slosh dynamics in space and on our body? Do our bodies experience slosh dynamics? And will we have to deal with that when we travel in space?
Are you talking tidal effects from the moon?
Well, he used that term.
Her.
Sorry. He used that term. I know it can be applied to different things, but it seems like I've heard about something about astronauts and something that slosh can affect their bodies.
Well, one thing is that when an astronaut is in orbit, they're in microgravity, so it means they're in a perpetual state of falling. Kind of in that state where you're going down the hill in the roller coaster, your stomach comes out from underneath you. Okay, yeah, imagine that 24/7.
Yeah.
Okay, I really want to try that someday with the Vomit Comet aircraft. Okay, of course, I'm sure I'll give it its name, but most fun I'll have being sick. But the thing is, the dynamics of the human body are affected by gravity, for one thing, and when they go into microgravity, one thing that happens is, in your body, when you're on Earth, the heart is pumping blood up to the brain. But in space, there is no up. So the fluids balance out. In fact, you get puffier in space. You go from like this to maybe, I don't know, it's not that bad, but you do puff out a little because the body fluids are redistributing and balancing throughout your body in even directions. So, but as far as tidal forces, I don't think that the tidal forces that are affecting you are going to play any role other than the fact that we live in a gravitational field. You go to the beach all the time when you see high tide and low tide. Well, the moon's differential gravitational effect, as well as the sun's, is affecting you, but you don't really notice it. But if we leave the Earth-Moon system and go out into deep space and leave the sun behind, well, then that's going to be a little bit different because then we're going to be in a condition where we've never experienced anything like that before. I mean, microgravity is microgravity. Close your eyes, you might not know the difference, but you might have different effects on your body without that solar radiation hitting you and without knowing the moon is there. I mean, there's going to be psychological effects on top of everything else. So that's what I feel about that. I don't know, Daryl, feel free to chime in on that.
Well, I'm a guy, so it's only
I know that.
speculation, but I have seen speculation before that the moon and its tidal effects can affect women's timing for childbirth.
Interesting.
I don't know the truth of it, but I've heard that before.
Interesting. I don't either.
I don't either.
Wow. That's pretty fascinating, though.
It is. I wouldn't be surprised.
I don't think I would be surprised either.
So, okay, well, I have another question now onto something different. So, what type of spectrum analyzers would we use to look at exoplanets? Because wouldn't we have to go to an exoplanet if we were going to habitate a planet in deep space? Do we need to know their mineral content before we head out there, even if it's in the thing that'll get us there in 3 weeks versus a million light years?
I think that's a very important thing to study, because if we don't know the mineralogy, we could show up there and find out it's one gigantic reactor, natural reactor, which would be detrimental to human life. But we need to know the constituents of the atmosphere. So long before we would ever go there, we would know whether it had an oxygen, nitrogen atmosphere that we could breathe. Based on what developed at the Earth, we don't necessarily expect that it's going to show up elsewhere exactly the same way.
Yeah. Are you kind of getting into vitamins and minerals sort of thing, Tara?
Well, I would think that if we go somewhere, we would have to maintain some of what we've developed here on Earth. And how do we know what to bring? What if we can't replicate that?
Absolutely.
And so I was wondering, what kind of instruments do we have to test that sort of thing? Do we have those even developed yet? Yeah,
I don't necessarily think that we have developed all the things that we will need for interstellar space travel like that.
Okay.
Yeah, I would wonder a little closer to home in the case of Mars. I know they have geology experiments on the spacecraft we sent to Mars and the landers and such. They might be pretty crude depending on, compared to what they might need for actual colonization. But I bet you dollars to donuts, people have already thought about this in the case of Mars. What's the mineralogy up there? And what would humans need to survive there, of course, in a bigger sense?
Yeah.
Well, it's kind of like traveling. Yeah, go ahead.
Is there calcium? We know the oxygen's bound up in the iron in the soil. But, it's the vitamins and mineral things. Does Mars have what we need to live and survive there long term?
Can we 3D print those minerals?
Actually, that's kind of funny you mentioned that. Probably not. But we should be able to disassemble other components to get those minerals, because we'll find them in other rock strata, perhaps. Like on the moon, we can extract titanium. We can extract helium-3 and use that as a fusion product, a fusion fuel. Skip a bunch of steps to get to helium-3 and just get the helium-3 directly and use that in a fusion reactor, for instance. But Martian soil, it's going to have a lot of iron in it. It's going to have iron, so we're going to be able to make metals if we have to. But the most important thing is to be able to make oxygen. And we're not going to be able to bring oxygen to Mars, because that's just too cumbersome and too much of a demand, because it's going to take over a year to get there. Let's say 10 months. And in that time frame, if the astronauts haven't gone completely nuts on their little spacecraft going there, when they get to Mars, they're going to want to run out and play in the sand. But they're not going to be able to do it for long, because they're going to need oxygen. So That's why the MOXIE experiment, the Mars Oxygen in Situ experiment that occurred on the Perseverance rover that they actually included, was so important, because it took the carbon dioxide in the air and it converted it to O2, breathable oxygen. Now, and it worked beautifully. Another byproduct of that is carbon monoxide, which is CO. Okay, so it took CO2, it made CO and O2. Okay, and that's all wonderful and great, except that we have a lot of CO that's going to go into the Martian atmosphere, which, of course, we know as a pollutant. Okay, but we're going to have an awful lot of oxygen that we'll be able to breathe, and we'll be able to create, say, a biodome, a domed city that will have oxygen. And all we need are these gigantic oxygen generators to make oxygen for astronauts. Then we need water. Okay. Well, that's not going to be as difficult as it appears, because Mars actually has a lot of water. It's locked up in the crust. It's locked up as ice below the surface, and we'll be able to get to that and make water to drink. So we'll have water, we'll have oxygen. But there's not any cows to milk. Okay, so where are we going to get the calcium that we need? Well, that's
vitamin C.
Well, that's vitamin C. We're going to need that. We need vitamin D, right?
The voyagers on the oceans back in the day, they suffered scurvy from lack of vitamin C.
Right. That's why
I'm
they
sure
brought oranges.
when we go there, early on at least, we'll be taking our vitamins and minerals with us, but if they're going to live there for a long time, they're going to have to come up with ways to synthesize it on Mars.
Well, what they'll do is they're probably going to end up starting greenhouses in those oxygenated domes. And then those greenhouses are going to supplement the oxygen input. They're going to scrub carbon dioxide. Okay. And thus it'll make it easier long term to spend a longer time on Mars. Yeah. And we'll be growing fruits and vegetables on Mars.
Bringing seeds, right?
Yeah, bringing seeds. But we're first going to have to treat the soil, because the soil has been sterilized by ultraviolet radiation striking it for billions of years. So early on, we may have to bring our own soil, because you can't grow that. Okay, we have to make it. So we're going to take Martian. That sounds like going to the beach and saying, I'm going to take this sand and grow plants. Good luck. You're not going to do it without nitrogen. You're not going to do it without phosphorus. You're not going to do it without the stuff required to grow plants. Yeah. Dirt and sand are two different things. And Mars may be more like a very, very sharp sand as opposed to a dirt.
Yeah, I've heard there are lots of perchlorates in the Martian soil also.
Yeah.
And which is poisonous to us. Yeah. And they're going to have to get rid of that.
Yeah. There has to be a way to work it out.
Work it.
You see that? That's very cool, though. Great question. We probably have time for another one if you want.
Real quick, because I think we're running out. But that simulation movie that you were showing us, did they go to the future? And can we know when the next explosion will be? And can we prepare for that?
Well, if we could tell that, then we wouldn't have to be here. I mean,
I know. I want to know. People want to know this stuff.
I know. No, but it only goes to present day, right to now.
Well, some simulations can run further, and it's interesting to see what they predict. I didn't know if that did it.
Well, volcanoes are a classic example. We don't know when they're going to go off.
That's
and one really good volcano can make a huge difference here on the planet.
Yeah. Don't you know? Don't you know?
Yeah.
That's right.
Oh, yeah.
Oh, yeah. I'm going to...
And when you said life formed when the first crust formed, was that a coincidence?
Well, it needs to have a foothold. It needs some place that it can lodge and percolate. And that was in the early oceans.
Right.
Okay. So that's what that was about. Now...
we are out of time.
We are. And I just wanted to... Good. I'm gonna put up the link to where this is, and so this is the link to that in the chat right now. So it'll be preserved. Just click on it, and it'll take you to this automatic, this wonderful History of the Earth simulation.
Cool.
But guys, thank you, Tara.
Thanks everyone.
Great questions
Good night,
as
everybody.
usual. Thank you, Daryl.
Sure.
I wish I could say we're going to stream after this, but the telescope's being installed, and I'll give you updates on the new telescope that we're getting for it as well.
Exciting.
All right. See you next week. Good night.
Take care.